Okay, this is a fairly involved problem because what we're dealing here with is really a dihybrid cross. And so what we got to do is see what kind of genes we're dealing with. It says gene B determines whether black or chocolate, so black is a capital B, chocolate is a lowercase b, pigment is produced. Gene E, since this is epistasis, is going to control whether or not these other genes that produce either the dark color or the chocolate color actually show up. So what it tells you is if there is two lowercase e's, any combination has two lowercase e's, are going to cause yellow lab color, despite what these colors are telling you right here. So the actual problem is if you have two chocolate labs, well, the way that you get chocolate labs is you're going to have two lowercase b's. So we're just going to write the cross over here. We know that both parents, we don't know this here quite yet, so I'm just going to leave this out. In order to be chocolate, have to be two lowercase b's, because if there is one capital B, they'd be black. That's not the case since they're both chocolate. And then it says it's heterozygous for gene E. Okay, so it's a capital E, lowercase e, capital E, lowercase e. And so that's the cross we're going to carry out. I'm going to use the FOIL method in order to figure out our combinations. And since both parents are the same, I'll be able to repeat this. So I'm going to end up having a lowercase b, capital E, lowercase b, lowercase e. I'm going to have again, a lowercase b, a capital E, and I'm going to have a lowercase b, lowercase e. Right, and it's going to look exactly the same over here. Reason it looks the same, both parents are the same, so you can reuse that. It saves you a little bit of time when you're working one of these big problems. Okay, when I put these together, make sure you keep your B's together and your E's together, just like you did with the parents. Okay, and we're going to look at this one. Two capital E's, and this one's going to be like this. Okay, then we're going to come back down to here, see what we get off of this one. Okay, moving on. This is just a matter of matching these things up. Now, if I would have set this up in a little bit of a different way, I could be saving some time right now. But that's alright. That way you can see how these all play out. Okay, that should be our Punnett square. So now we got to go through and figure out what we've got. Now, if you look at what I did compared to what's over here, I have the E's first, followed by the B's. Not a problem. It still will all work out the same. So I'm going to go ahead and look at ones where I have two capital E's and two lowercase b's. I've got one here. I've got one here. One here. One here. So it looks like we're dealing with four that have two capital E's, two lowercase b's. Okay, our next combination we have two lowercase b's and a capital E and a lowercase e. So I've got one here, I've got one here, one here, one here, one here, one there. So that means that I have 6 of those. Okay, so two lowercase b's. Deal's right there. Okay, this next one, we have two lowercase b's, two lowercase e's. Got one here, one here, one here, one here. So I've got 4 of those. And if you look, I ended up missing a couple right here in my original count. So I can go ahead and add those back into these that we've already counted. Two lowercase b's, a capital E, and a lowercase e, which was right here. So we're going to go ahead and Change that to 8. And we're just going to double check to make sure I didn't miss any at this point. I'm going to check those off my list. 8 plus 4 is 12. 12 plus 4 is 16. We should have 16 total. So we'll go ahead and figure out what we have. Anything with a capital E is going to allow pigment to show up. Anything with lowercase e's, you're not going to have any pigment. So we're going to end up with 12 chocolate labs. And the reason they're chocolate is because there is lowercase b. If I look at this one over here, I have 2 lowercase e's, which means it doesn't matter what these lowercase b's are. It is going to be a yellow lab. So we're going to end up having 4 yellow labs. And again, our number should equal 16. Since there are no blacks in this one, you can go ahead and put a 0 in there. And so what we end up with is seeing that the letter E in this case is going to control the outcome of this genetic cross, causing yellows to happen in its recessive state.